In permutation and combination, we will go with the thematic based learning approach so that you will understand very, very clearly each and every idea and its execution. Thematic based learning, what we'll do is, in this one, first thing what we'll do is fundamental principle of counting. Fundamental principle of counting. Fundamental principle of counting. Generally in our textbook, they discuss only two rules. One is AND rule, another is OR rule, which we call it as, one is a multiplication rule, one is a multiplication rule, another is an addition rule. Multiplication rule and another is an addition rule. But in addition to these two rules, there are two more rules. One is a subtraction rule, which we call it as a rule of negation also in standard textbooks. Subtraction rule or rule of negation. Subtraction rule, which we call it as a rule of negation. And another is nothing but a division rule. Another is nothing but a division rule, which is extremely important. This leads us to one very beautiful concept in permutation and combination, that is PGN whole principle. PGN whole principle. There are four fundamental principles of counting. One is a multiplication rule, another is an addition rule. Each one has evolved with a question asked. Multiplication rule. Multiplication rule is used if one event follows another event. If one event follows other event, then multiplication rule is used. Multiplication rule is used if it is, 1 minute sir, it is, the process is happening serially. Please write down sir, write down as it is. The process is happening serially. A to B, B to C. B to C is following A to B. So it is multiplication rule. Addition rule. Addition rule is used if the events are happening parallelly. If the events are happening parallelly, then addition rule is used, right? If I want rule of negation, negation is nothing but total minus the total cases where the condition is achieved. How many 3-digit numbers do not have digit 5 in them? How many 2-digit numbers do not have 2 digit in them? Do not have negation, rule of negation. Total minus cases where the condition is achieved. Total minus cases where the condition is achieved. I'll again write division rule. Division rule is, suppose there are 3 classes. There are C1, C2 and C3. There are 3 classes available. There are 30 students. There are 30 students to be arranged in 3 classes. Each class will have equally, if I say that each one should have equal number of students, 10, 10, 10, 10, 10, 10, 10, 10. Division rule helps us in dividing the total number of cases based on a condition. So from now onwards, in fundamental principle of counting, not only 2 rules are there, there are 4 rules. Multiplication rule is used in a serial processing. Addition rule is used in a parallel processing. Subtraction rule is used. Suppose there is a condition that is given in the question. If you satisfy the condition, you will get some cases. But I want the cases which do not satisfy the condition. The cases which do not satisfy the condition. If I want the negation, if I want not cases, then I will go for the subtraction rule. If I want that condition should be satisfied across multiple groups, I will use a division rule. Multiplication rule, addition rule, subtraction rule and division rule. Division rule, I will take a special class on a PGN whole principle. Extremely important. Students who are from a computer science or an electrical background, you might have said, You might have studied, suppose there are 8 chocolates are there and there are 7 students are there. So that means each and every student should get minimum 1 chocolate. If that condition is specified, Pigeonhole principle says that there should be at least 1 student who got more than 1 chocolate. Pigeonhole principle is extremely important. That will be our last class along with the de-arrangement based questions. Everything, right, I will discuss right after the class. It will be over, right? The class will be made private for the enrolled students. You can watch the class as early as possible. These are the 4 things. One by one we will go. First one, remember, permutation and combination. These are the nomenclatures. These are the nomenclatures, or these are the names that are given to you. These are the names that is nothing but given to you. I will try my level best not to use the word permutation and combination and solve a lot of problems. First one, multiplication rule. What is this multiplication rule? Suppose there are these nothing but a serial processing. What do you mean by serial processing? Events are not happening one at a time. Events are happening one after the other. Please write down, sir. I will go very slow because it's a foundation class. Events are happening one after the other. Events are happening one after the other. If one event happens after the other event, then I will use a multiplication rule. Suppose Anil Nair is there at Hyderabad. He has to go to his native, that is in Kerala, which for example, if it is Palakkad, right? He will go from Hyderabad to Coimbatore and Coimbatore to Palakkad. Hyderabad to Coimbatore, if there are 3 ways, and Coimbatore to Palakkad if there are 2 ways. One is by road, another is by train. So events are happening one event one after the other. One event one is going from A to B. And what is the second event? Second event is from B to C. That means here how many ways are there? 3 ways are there. Here how many ways are there? 2 ways are there. For example, if I take the first way, for example, if it is flight, if it is rail, and if it is bus. If I take a flight from Hyderabad to Coimbatore, if I take this way, I can go from Coimbatore to Palakkad either by rail or by bus. That means F can take either R or B. Suppose if I take a rail, right, I can reach Coimbatore to Palakkad either rail or bus. If I take a bus and reach Coimbatore either rail or bus, 2. How many cases I got? 6 cases. 6 cases is nothing but 3 into 2. Each one is giving you 2 cases. Like that, there are 3 cases in event 1. Event 2 is following event 1. When event 2 is following event 1, then I will use fundamental principle of multiplication. One event is happening and after the other event. This is the most popular fundamental principle, which we call it as an AND rule. What do you mean by an AND rule? AND rule says that one event will happen after the other event. If the first event takes P ways, and the second event takes Q ways, right? The total number of ways of having event 2 after event 1 or event 1 after event 2 is P into Q ways. This is multiplication rule. Again, I am repeating, there will be a good chance where most of the students get confused between permutation and combination because they have not understood the fundamental principle of counting very, very well. Listen carefully to each and every example of mine. Just give some hours of your time with me. I will ensure that permutation and combination becomes a very interesting area for you, right? Now multiplication rule. Remember, multiplication rule is for the serial processing. Serial processing is one event is happening after another event is over. Reaching Hyderabad to Coimbatore is over. Then only I am moving from Coimbatore to Palakkad. I cannot talk about Coimbatore to Palakkad without reaching Coimbatore through how many ways? Multiplication rule. Multiplication rule. Now see this example. See this example. Right. Now this is one classical example which I took from NCERT textbook. Suppose there is a chalk piece. There are three kinds of chalk pieces. Each chalk piece is of 3 different length. Each chalk piece is of 8 different colors. Each chalk piece is of different diameters. Some are thick, some are thin, some are very, very thin and everything. So there are 3 kinds of chalk pieces that are available in the market. How many different kinds of chalks are there? Now see, what are the 3 events that are there? First, I have to select based on length, event 1. Then I have to select based on color, that is event 2. Then I have to select based on diameter, that is event 3. First is based on length, then next is based on color, next is based on diameter. So in terms of length, how many are there? 3 different lengths are there. Event 1 is over. Event 2, I have to choose a chalk piece based on color. How many are there? 8 different colors are there. In the previous example, traveling ways are 8. Here, colors are 8. That's the only difference. Then, in terms of diameters, how many are there? 4. Now, if you see, there is a keyword and. There is a keyword and. And means one after the other, the event is happening. If one after the other, one event is happening, then I will use a fundamental principle of multiplication. 3 into 8 into 4 is there. Immediately when you read the question, you will understand whether it is fundamental principle of multiplication or fundamental principle of addition. Why? Why? Because if you read the question, and 4 different diameters are there. This is there, and it is there. And is one after the other. First is color, next is length, next is diameter, or you can take any combination. So 3 into 8 into 4. 3 into 8 into 4. I hope it is clear. Another example. Right, suppose a student has to take, suppose in case if you are doing engineering, in your 3rd semester or a 4th semester, in case if you are studying in an autonomous university, you have to go for some elective courses, right? So in the elective courses, suppose there are 3 courses, so one random example, there are 3 courses available on artificial intelligence, compiler design, and probably another neural networks. Similarly, there are 4 courses available. So in total 3 courses here and 4 courses here. 3 into 4 is 12. 3 into 4 is 12. So another classical example based on scheduling. One important key point again I am explaining. First task and second task. First task and second task. First task and second task. I hope it is clear, right? This is one example. Next one, we will do with respect to digits so that it will be clear. So that it will be clear. So that it will be clear, right? Permutation and combination, fundamental principle of multiplication is over. Next is addition rule. Next is an addition rule. When this addition rule is used, sir, you said that one event is following another event. What if event happens parallelly? Both the events are happening simultaneously. Please write down. Both the events are happening simultaneously. If both the events are happening simultaneously, then I will use addition rule. If both the events are happening simultaneously, then I will use addition rule. Addition rule is for parallel processing. 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 Suppose I am there at Hyderabad. I have to go to Palakkad. Either I can choose flight or I can choose rail. or I can choose bus, or I can choose bus. All the three events are happening parallelly at the same time. From 9:30 in railway station, a train is starting. From airport, flight is starting. From Imli one bus stand, one bus is starting. Anil Nair can start from Hyderabad and reach Palakkad through these three different ways. All the three events are happening simultaneously, not one after the other. All the three events are independent of each other. All the three events are independent of on each other. Please write down as it is, sir. All the three events are independent on each other. Because it is independent of each other, in the previous case, going from Coimbatore to Palakkad, two ways are there. Going from Hyderabad to Coimbatore, three ways are there. So 3 into 2, because second event is following first event. Here all the three events are happening at the same time. Multiplication rule is used for serial processing. Addition rule is used for parallel processing. Addition rule is used for parallel processing. Either this or this or this. So answer is nothing but three ways. Answer is nothing but three ways. One is and rule, another is or rule. And rule is used when one event follows the another event. Or rule is used when all the events are happening at the same time. One is for serial processing, another is for parallel processing. Another example. Now see here. Suppose if you see here, take this example. Suppose there are the number of ways a man, woman, boy and a girl can be selected from 5 men, 6 women, 2 boys and 4 girls. Whenever there is an and condition, I have to select a man from 5 men. So either it could be M1 or M2 or M3 or M4 or M5, 5 ways. Or similarly, from 6 women, I have to select 1 woman, right? It could be W1, W2 into 6. The important keyword is and. So 5 into 6 into 2 into 4. 5 into 6 into 2 into 4. Suppose if the question is like this, in how many ways one person can be selected? In how many ways a one person can be selected? There are men in my class, there are women in my class, there are boys in my class, there are girls in my class. In how many ways can I select a person? The person whom I select could be either man or woman or boy or girl. Or boy or girl, right? So if it is, in how many ways can I select one person, which is nothing but 5 plus 6 plus 2 plus 4, which is 17. Our condition is addition and condition is into. Our condition is addition. I hope this example is also clear, right? Next one, subtraction principle. Basic example I will take it, but when I am doing an arrangement of digits, I will again come back to it. Subtraction principle. I told you that subtraction principle is nothing but total cases minus cases where the condition is satisfied. Total cases minus cases where the condition is satisfied. If I do the negation, right, this is popularly known as the rule of negation. If I popularly known as the rule of negation. When simple example is, suppose there are 26 alphabets are there. In these 26 alphabets, suppose if I ask, how many vowels are there? Vowels are nothing but 5. This is the condition. Suppose if I say, how many consonants are there? This is nothing but total cases is 26. Minus cases where the condition is satisfied is 5. 26 minus 5 is nothing but 21. Subtraction rule is nothing but the rule of negation. Subtraction rule is nothing but the rule of negation. Rule of negation. 1 minute, sir. Is satisfied is 5. Is there any voice lag happening? Kindly reply if there is any voice lag. This is exactly one of the reasons why I don't take free classes for everybody in the YouTube channel. People come and write whatever they want, right? Satvik says there is a voice lag. I am sure there is no voice lag, right? Everybody will write whatever they want because anonymity, right? Somewhere, right, I wanted to help students in the areas which they are struggling, but there are certain bad elements who will disturb the class, right? I hope it is clear now. There is no voice lag, right? Satvik, only you are telling, nobody else is telling that there is a voice lag. Is there anybody else who feels that there is a voice lag? Voice lag, only Satvik is telling, right? So I think one student's feedback should not be considered too seriously. If too many people are telling, then it's an issue, right? Subtraction principle. Next, last one, because most of you do not go through these principles at the beginning of the class. Another is division principle. Division principle is nothing but the, for example, right? There are 740 pigeons in a collection of, right? Total there are 740 pigeons. Suppose we will put it like this. There are 200 students are there and there are 5 classes are there. So each class will have how many students? 40 students. So generally these very popularly we use it, right, in a pigeonhole principle. Pigeonhole principle. I hope it is clear. So these 40 students. Now we will get into a problem solving. Listen carefully, sir, one by one. But right? See the first things. Ayush has 3 jeans and 2 shorts. Immediately, because I said and rule, right? And rule without using mind, people will say that it is 3 into 2. Answer is nothing but 6. That is how most of the students will do this mistake, because they mugged up the things. Read the question. Ayush has 3 jeans and 2 shorts. Right? That means either he can wear jeans or he can wear shorts. Unlike he is a Pawan Kalyan who will wear one above the other, right? That only happens in movies. So it is, even though it seems to be 3, he has 3 jeans and 2 shorts, does not mean there are 6 ways. He can either wear jeans or shorts, right? So answer is nothing but 3 plus 2, which is nothing but 5. Silly mistake students will try to commit it. Please do not give any answers, sir. Please do not give any answers. Sir, to all the viewers who are watching this class, if I find this class having little bit of disturbances where the students keep giving answers without me asking, write something which is irrelevant. Probably from the next class onwards, I will try to send the class link only to the students who are there in my group. Other students, right, please don't ask. This is exactly the reason why I generally my class gets disturbed if the people, right, tell the answers. Now I have seen people telling the answers. I don't know who has asked them to say the answers. Did I ask Satvik to tell the answer? Why are you telling the answer when nobody has asked you what is the answer? I will ask a question to tell the answer. At that time, tell the answer. Right? So 3 plus 2, it is nothing but 5. You can use your brains when I give a problem to you. At that time, anyway, you will not get the answer. Right? First. Second one. Now, exam related question. We will see. Please write down, sir. This is the first one. Now, second one. Please write down. Suppose there is an 8 into 8 chessboard. 8 into 8 chessboard. In an 8 into 8 chessboard, there are 32 black squares and there are 32 white squares. There are 32 white squares. In how many ways can I choose? In how many ways can I choose a black and a white square? In how many ways can I choose a black and a white square such that they do not lie in same row or same column? Same row or same column. Same row or same column. Right? There is an 8 into 8 chessboard. In an 8 into 8 chessboard, there will be 32 black and 32 white. In how many ways can I choose a black and a white square such that they do not lie in the same row or same column? Listen carefully, sir. This one example, once you understand this example, then it will be extremely clear for you, right? There is an 8 into 8 chessboard. Suppose if there is a 2 into 2 chessboard, if there is a 2 into 2 chessboard, this is a 2 into 2 chessboard. This is a 2 into 2 chessboard. How many horizontal lines are there? 1, 2, 3. How many vertical lines are there? 1, 2, 3. In a 2 into 2 chessboard, there will be 3 horizontal lines and there will be 3 vertical lines. There will be 3 horizontal lines and 3 vertical lines. In an 8 into 8 chessboard, there will be 9 horizontal lines and 9 vertical lines. That is the first important key point. In an 8 into 8 chessboard, there will be 9 horizontal and 9 vertical. Suppose some important note. I want the total number of rectangles. Rectangle is nothing but 2 horizontal, 2 vertical. This is nothing but a rectangle. To draw a rectangle, I require 2 horizontal lines and 2 vertical lines. To draw a rectangle, I require 2 horizontal and 2 vertical. So, in an 8 into 8 chessboard, there are 9 horizontal lines. If the question is number of rectangles, I need to select any 2 horizontal lines. Out of 9 vertical lines, select any 2 vertical lines. This event is happening after this event. So, it is into 9C2 into 9C2. 9C2 into 9C2. Again, I am explaining. First, we will solve some easy questions. Then I will get into that one. In an 8 into 8 chessboard, how many horizontal lines will be there? 9 horizontal lines and 9 vertical lines. To draw a rectangle, I require 2 horizontal lines and 2 vertical lines. Out of 9 horizontal lines, I need to select any 2. Out of 9 vertical lines, I need to select any 2. 9C2 into 9C2. Suppose if the question is 7 into 5 chessboard. If it is 7 into 5 chessboard, 7 into 5 means, 7 means there will be 8 horizontal lines. 5 means there will be 6 vertical lines. In 8 horizontal, to draw a rectangle, I require 2 horizontal and 2 vertical lines. So, answer is 8C2 into 6C2. 8C2 into 6C2. Like that, you can keep creating as many questions as possible. If the question is 9 into 7 chessboard, in a 9 into 7 chessboard, there will be 10 horizontal lines and 8 vertical lines. Because in a 2 into 2 chessboard, there will be 3 horizontal, 3. In an M into N chessboard, there will be M plus 1 horizontal lines and there will be N plus 1 vertical lines. N plus 1 vertical lines. So, if the question is a number of rectangles, which is extremely important, so these is nothing but 2 horizontal and 2 vertical. So 10C2 into 8C2. First most important concept of how to find the number of rectangles in an M into N chessboard. I hope the idea is clear. You don't need to mug up any formula. Number of rectangles. I hope the idea it is clear. 8 into 8 chessboard, 7 into 5 chessboard, 9 into 7 chessboard. Now, let us solve the question whatever came in the examination. I hope this idea is clear. To draw a rectangle, I require 2 horizontal lines and 2 vertical lines. This is my requirement. What is required from what is given in the question? Now, let us see the first question. In an 8 into 8 chessboard, there will be how many horizontal lines? 9 horizontal lines will be there. And 9 vertical lines will be there. 9 horizontal. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here again 1, 2, 3, 4, 5, 6, 7, 8 and the last one is 9. This is nothing but an 8 into 8 chessboard. What is the question that he is asking? In how many ways can I choose a black and a white square? Such that they do not lie in same row or same column. If anytime you played chess, it will be like this. If this is black, this will be white, this will be black, this will be white, this will be white, this will be black, white and black. Let me take this strip. These white, these black, these white, white, black, white, black. There will be 32 black and 32 white in an 18 to 8 chessboard. What is the question that he is asking? In how many ways can I choose a black and a white square such that they do not lie in the same row? Black and white do not lie in the same row or same column. Suppose if I choose these black, I cannot have white in the same row, same column. So, upper 2 whites are eliminated. They cannot lie in the same row. Down 2 whites are eliminated. Left side 2 whites are eliminated. Right side 2 whites are eliminated. Top 2, bottom 2, left 2, right 2. 8 whites are eliminated. So, out of 32 whites, 8 whites are eliminated. So, if I choose that one black, 24 whites I can choose. 8 I cannot choose. What are that 8 I cannot choose? 2 top, 2 bottom, 2 left, 2 right. So if I choose these black, 24 whites I can choose. But according to the question, there are 32 blacks are there. So answer is 32 into 24. Answer is nothing but 768. Answer is nothing but 768. In how many ways can I choose a black and a white square such that they do not lie in same row or same column? If I choose these black, I cannot choose white in the same row or same column. Same row. Upar do, niche do, left do, right do. Total 8 whites, I cannot choose it. Suppose you might ask a question, hey Anil sir, instead of these black, suppose if I take these white, that also will give you the same answer. If I choose one white, 1, 2, 3, 4, 1, 2, even if you take this strip and this strip, total 8 blacks cannot be chosen. If one white is selected, you can choose white. If this is black, WB, this is B, WB, W. If I choose this white, BB, 4 is out. BB, 4 is out. 8 blacks are out. So for one white, 8 Bs are out, 24 are remaining. So 24 into 32, 768. So 32 into 24 is 768. Extremely important question. Extremely important question. Answer is nothing but 768. Answer is nothing but 768. Idea is clear, right? 32 into 24 is 768. 768. That is one good question, right? We will do a lot of, second class will be a very interesting class. Probably I'll try to make the class unlisted. Just don't go in hurry and tick mark. Answer as 6. It is jeans and 2 shorts are there. So both can be right. We wore either this or this. So 3 plus 2, answer is nothing but 5. Now, Ravi has 3 pants and 2 shirts. So Ravi has 3 pants and 2 shirts. So if I call it as pant 1, pant 2, shirts is S1 and S2. So he can wear it pant down and shirt here. So it is and condition. So answer is nothing but 2 into 2. 2 into 2 is nothing but answer 4. Answer is 4. Very, very easy question. Next one. Now these question is also to make you understand the concept, right? Suppose there is a person, Siddharth, he has 3 jeans, 2 shorts and 2 shirts. How many different pairs of a pant, short and a shirt can he dress up with? Either he can choose jeans and shirt, jeans and shorts, or he can also go with shorts and shirts. Shorts and shirts, right? So that he will be completely dressed up. So there are 3 jeans here, shorts are nothing but 2 and condition into R is nothing but plus, shorts here it is nothing but 2, shirts is 2. So 6 plus 4, it is nothing but 10. So that in how many ways he can dress up? Answer is nothing but 10. So total Siddharth, by having jeans, shorts and shirts, he can dress up total is nothing but 10 ways. Fundamental principle of counting. Now please write down. How many 4-digit numbers exist? Next one. How many 4-digit numbers exist? How many 4-digit numbers exist? Before we solve the problem, the digits are nothing but from 0 to 9. Digits are nothing but 0 to 9. First important key point. Second key point. Suppose a number is there. For example, 333 is there. The digit 3 is repeated thrice. That means by default, repetition of the digits is allowed. Please write down. In a numbers, by default, repetition of digits is allowed. By default, repetition of digits is allowed. If nothing is given in the question, still the repetition of the digits is allowed. Still the repetition of the digits is allowed. Third key point. Because it is a 4-digit number, the form of that number is ABCD. Leftmost it is A. Leftmost it is nothing but A. Leftmost cannot take 0 to become a 4-digit number. There is a case where it will take 0. That also we will see it. Leftmost A. It can take any digits from 1 to 9. Either it can take 1 or 2 or 3 or 4 or 9. So total 9 cases are there. Similarly, B. B can take any digits from 0 to 9. 0 to 9. Either 0 or 1 or 2 or 3 or 9. So 10 cases. Next one it is C. Either 0 or 1 or 2 or 3 or 9. Again 10 cases. D is nothing but either 0 or 9. 10 cases. First I am arranging A. Arranging B. This event is following this event. This event is following this event. This event is following this event. One event is following another event. Serial processing. So it is a fundamental principle of multiplication. 9 into 10 into 10, which is nothing but 9 into, right? 9 into 10 cube. 9 into 10 cube. 9 into 10 cube. A is nothing but 1 to 9, which is nothing but 9. B is from 0 to 9, C is from 0 to 9, right? D is from 0 to 9. 9 into 10 cube. 9 into 10 cube. Answer is nothing but 9 into 10 cube. I hope the idea it is clear. A simple example to tell you how the fundamental principle of multiplication can be used to count the numbers. So total number of 4-digit numbers are nothing but 9 into 10 cube. 9 into 10 cube. I hope it is clear, right? To all the students who are listening class, right now, by this time you should have understood the kind of disturbances people will create because I am not charging anything from them, right? Somebody, Suvanshi, is saying hello OA, right? What kind of happiness he gets in writing all these messages, I don't know, right? People come, right? 9 into 10 cube. 9 into 10 cube. I hope the idea it is clear, right? Next, second question. Please write down, sir. Next class, I will send you the class link, sir, so that only selected can only attend. Second one. Please write down. Four-digit number we did, right? Next question. How many 4-digit? First, I will go with the basics, sir. Basic problem. So many practice classes I will do it for you. How many 4-digit even numbers exist? How many 4-digit even numbers exist? Second class will be very interesting. Don't miss the class, sir. How many 4-digit even numbers exist? How many 4-digit even numbers exist? 4 digits. 4-digit even numbers. First, always concentrate on the condition. How many 4-digit even numbers exist? A number is said to be an even number if the unit digit is an even number. If the unit digit is an even number. So, unit digit has to take an even place including 0. That means unit digit could be either 0 or 2 or 4 or 6 or 8. 0, 2, 4, 6 or 8. 0, 2, 4, 6 or 8. Leftmost cannot take 0. It can take any value from 1 to 9. There is no restriction on the values which are at tens place and hundreds place. So it is 0 to 9. And these also nothing but 0 to 9. 1 to 9, there are 9 values it can take. 0 to 9 is 10. 0 to 9 is 10. 0, 2, 4, 6 or 8. 0, 2, 4, 6 or 8. Total 5 values are there. Answer is nothing but 45 into 10 square. Answer is nothing but 45 into 10 square. How many 4-digit even numbers are there? First, satisfy the condition, right, which is given in the question. It is an even number. A number is said to be an even number if the unit digit is nothing but an even number. Even, right? Even number. 0, 2, 4, 6 or 8. 0, 2, 4, 6 or 8 is nothing but 5. 1 to 9 is nothing but 9. 0 to 9, 0 to 9. 9 into 10 into 10 into 5, which is nothing but 45 into 10 square. 45 into 10 square. I hope the idea it is clear. Next one, another question. Right, go basics problem by problem, sir. How many 4-digit odd numbers exist? 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 Another question. Because it's a 4-digit number, first it keep units place, tens place, hundreds place and thousand place. A number is said to be an odd number if the units place it is an odd number. First, satisfy the condition. Units place should be odd. Odd means which all cases? 1, 3, 5, 7 and 9. 1, 3, 5, 7 and 9. That is the condition. Condition is satisfied. So leftmost 0 cannot come. So it has to be 1 to 9. Here there is no restriction. 0 to 9. Here there is no restriction. Right? 0 to 9. D is nothing but 9 into 10 into 10 into. Next is nothing but 5. D is nothing but 45 into 10 square. 45 into 10 square. I hope the idea it is clear. How many 4-digit odd numbers exist? Answer is nothing but 45 into 10 square. 45 into 10 square. Another question. Another one. Right? Please write down. How many 4-digit palindromic numbers exist? How many 4-digit palindromic numbers exist? How many 4-digit palindromic numbers exist? Another variety. As you know, in the class I will discuss as many variety of questions as possible so that you are extremely comfortable with variety of the problems. How many 4-digit palindromic numbers? First we will underline the keyword palindrome. Palindrome could be in alphabets, could be in numbers. In alphabets, Liril is a palindrome. Left to right, right to left. Amma is a palindrome. Amma is a palindrome. In numbers, 1 to 1 is a palindrome. 2 double 3 2. These are a palindrome. Palindrome means left to right and right to left. Left to right and right to left. Left to right and right to left. It is same. Left to right and right to left. It is same. Right? Left to right and right to left. All are same. Palindrome. Palindrome means left to right and right to left. All are same. It is a 4-digit. So A. Left to right, right to left, it should be same. B, left to right, right to left, it should be same. ABBA is the form of a 4-digit palindrome. ABBA is the form of a 4-digit palindrome. ABBA is the form of a 4-digit palindrome. Now leftmost cannot take 0. So if I keep 1 here, automatically this A will also be fixed. If I keep 2 here, automatically this will also be fixed. These is nothing but 1 to 9. These is nothing but 1 to 9. Leftmost, if I am fixing A, automatically rightmost also it is fixed. So you don't need to count it. Here it is nothing but 0 to 9. Automatically when I fix this B, these also B, so it is fixed. So in an 4-digit palindrome, determining how many values leftmost 2 takes, it is equivalent to determining how many values rightmost 2 will take. So these nothing but 9 into 10. 9 into 10 answer is nothing but 90. 9 into 10 answer is nothing but 90. A will take from 1 to 9. A will take from 1 to 9. And once I gave these A, automatically it is fixed. B will take from 0 to 9. These also fixed. So 9 into 10. 9 into 10 is nothing but 90. Why into came? One event is happening after another event. One event is happening after another event is happening. Right? Next question. Please write down. Right? Another question. How many 4-digit? Write down in the same order, sir. How many 4-digit palindromic odd numbers exist? How many 4-digit palindromic odd numbers exist? How many 4-digit palindromic odd numbers exist? Now see here. 4-digit. 4-digit it is nothing but ABBA. ABBA. Because it's an odd number, units place should be odd. Units place should be odd. Just to satisfy the condition. Units place odd means it can take 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. Automatically when I gave this value, this is automatically fixed. No need to do it. D is nothing but B can take any value from 0 to 9. B can take any value from 0 to 9. 0 to 9 is nothing but 10. A will take how many cases? 5 cases. So answer is nothing but 10 into 5 is nothing but 50. Answer is nothing but 10 into 5, 50. A, B, B, A. A, units place, it is nothing but odd. Odd means 1, 3, 5, 7 and 9. 1, 3, 5, 7 and 9. Right? So automatically these also fixed. These also fixed. So B, it can take any value from 0 to 9. So 10 into 5, it is nothing but 50. 10 into 5, it is nothing but 50.